One of the major challenges on your energy test was graphing. Some of that is related to what we've done with spring force in our experiments, but some of it is also just rules that College Board wants to make sure that you follow. So when you take notes on this page, please put it on a separate piece of paper that goes at the front of your binder so that you can reference it often when you're drawing and analyzing graphs. So the first big thing I noticed issues with was the best fit line. So take a second to think about all the criteria that your best fit line should follow. Perhaps the most obvious criteria is that it's a line, a straight line. I saw a lot of curves instead of straight lines drawn on your test. A way to make sure that your line is straight is to use a ruler or some other kind of straight edge. What's another criteria of a best fit line that you need to think about? You may have noticed in this diagram that we have the same number of points above our best fit line as we do below our best fit line. Although I didn't really follow this next rule in the diagram in the picture, it's still pretty important. You want to make sure that your line doesn't look like it's being forced through any particular points. That's because if you force your line through one or two particular points, you're putting more value on those points than other points. And the whole reason that you take many data points is so that you take into account the entire average in an experiment. So don't force your line through any data points. Those are the three most important things to think about when you draw a best fit line. When you find the slope of a best fit line, of course you use the slope equation. But where should I get these y and x components of points? A lot of students use data points from their data table. So these numbers in here, because they're easy, you already have them. However, College Board hates when you do that, even if your line of best fit looks like it goes through those points. So instead, you're going to try to find points on your line that do not include data points. I find it easiest to choose points that cross at a cross-section of your graph paper. So all these tick marks cross each other at certain points, and if your best fit line crosses where they cross, that's a good point to choose. So this, for example, is a good point to choose because it shows a point on my line where my x component is 0.1 and my y component is 1, and that's easy to see. So that's how I choose these points. Next, we're going to talk about how to choose what's on your x or y axis, because a lot of people flipped this and put stretch on the y-axis and force on the x-axis. So how do you decide what goes on the x and y axis? The reason that you probably know the best is identifying the independent and dependent variables. But sometimes it's hard to identify when two variables are so closely related, and with force and stretch, you're kind of changing both at the same time. So instead, I like to map to a linear equation. So the equation I know I need this graph to match is f equals kx. And when I look at that, it looks very similar to y equals mx plus b, where f is my y, x is my x, my stretch goes on my x-axis, and my slope is k. This brings us to point 4. To figure out the slope, this mapping is helpful too. If I map slope to k, then I know the slope of this line is k. And I also know, because there's no y-intercept in my f equals kx equation, that my y-intercept of my graph should be 0. This is a mistake that a lot of people made too, because instead of putting stretch on the x-axis, they put length, making their x-intercept all the way at 2 meters, because that was the original length. Instead, we want to take our data, figure out how much our spring is stretched past its original length, so this would be L minus L naught would give us x, and put that in the graph so that then our graph actually matches this equation, f equals kx. So we've talked about how to draw a best fit line, what points to use to calculate the slope of that best fit line, how to use the equation we know we're trying to map our data to figure out what goes on the x or y axis, and what the slope and y-intercept should be. Next, we will talk about the last open response question on your quiz.